Walk into any preserved medieval hall, church or bridge, and the timber supporting the roof or decking may still be solid, decades or centuries after it was cut. Modern wood in similar conditions would have rotted or cracked long ago. This is not a matter of luck or myth. It is the result of intentional methods developed by medieval builders to give timber extraordinary longevity. Understanding these methods transforms how we see wood, not as a fragile material to be thrown away after a decade, but as a resilient resource that can last generations. Medieval builders treated rot as a problem to starve rather than a battle to seal. Modern construction focuses on keeping moisture out with synthetic coatings and sealants, often trapping water inside instead. Medieval builders approached rot differently. They accepted that wood would get wet, and they designed a system to remove the fungi's food supply, manage moisture, and maintain strength. This meant that timber could safely experience rain, snow, and ground contact without succumbing to decay. The principle is simple. Fungi require moisture, oxygen, and nutrients. Medieval timber was treated to remove nutrients and allow water to move freely, making decay impossible to establish. Not all wood is equal, and medieval builders knew this. Slow-grown trees with dense heartwood were chosen for structural elements. Sapwood, rich in sugars and starches, was often avoided or trimmed away because it feeds fungi. Timber was felled during winter dormancy when sap content was lowest, reducing internal sugars and moisture content. For modern applications, selecting heartwood-rich lumber and cutting or sourcing wood during dormant seasons can immediately increase durability without chemical additives. One of the most effective medieval treatments was soaking timber in water for weeks, months, or even years. Rivers, ponds, and tidal zones were used to flush out sugars and starches while cold water slowed microbial activity. Timber, prepared this way, became naturally resistant to rot and insects long before any other treatment. Modern builders can apply this principle by soaking posts or beams before slowly drying them, especially for wood in direct contact with soil or exposed to weather. This practice can, dramatically increase lifespan. After soaking, timber was dried slowly under cover with airflow. This step could take months or even years. Slow drying prevented internal stress and allowed fibers to compress evenly, increasing density and toughness. By contrast, modern kiln drying removes moisture quickly, leaving wood stressed and well prone to cracking and rot once exposed to the elements. Air-dried timber is still one of the most resilient materials available, capable of handling repeated wetting and drying cycles. Medieval builders often exposed timber to controlled heat or surface charring. Light charring killed surface organisms, hardened fibers, and reduced moisture uptake. This step made subsequent protective treatments like oils or tars bond more effectively. Unlike modern coatings, which can crack and fail, this altered the wood itself, making it inherently durable. After drying and charring, timber was treated with natural oils, tallow waxes, or pine tar. Heated and applied to warm wood, these substances, well, they penetrated deeply, repelling water, deterring insects, and remaining flexible even in extreme weather. Reapplication over time allowed the wood to remain strong for decades, or honestly, even centuries. Modern applications should avoid merely brushing on cold finishes. Warmed oils or tar, applied to properly prepared wood, offer far greater protection than synthetic sealants. Design choices ensured water never lingered. Beyond treatment, medieval builders designed structures to shed water aggressively. Steep roofs, generous overhangs, elevated posts, and airflow around beams ensured that water drained quickly and timber remained dry between wettings. Water that lingers leads to rot. Water that moves through safely, well, it strengthens wood instead of destroying it. The final piece of the medieval method was maintenance. Surfaces were re-oiled or re-tarred, minor repairs addressed early, and buildings were inspected regularly. This ensured small issues never became structural failures. Modern reliance on, maintenance-free materials fails silently, but medieval practice embraced care as part of durability. Medieval timber was effectively immortal because every step, from tree selection to seasonal felling, soaking, slow drying, charring, oiling, smart design, and maintenance, worked toward longevity. For survivalists, homesteaders, and historical builders, these principles offer a proven system for creating structures that endure far beyond modern expectations. If this deep dive into medieval timber transformed your understanding of wood durability, support in the beginning by subscribing, sharing with fellow history enthusiasts, and helping preserve centuries of practical historical knowledge for future generations.